Oh yeah, look at that. Look at that end mill. So today we're going to talk about the actual applications of end mills and how to figure out what your end mill is supposed to be doing, and then some spots online where you can actually buy tools. This video is for people who don't really understand ISO classifications of tooling, speeds and feeds calculations, and just general stuff about tools. So today we're going to talk about this classification on the end mill. As you can see, you have the blue, yellow, red, green, kind of like an orangish color, and then a gray. They actually stand for something. So let me back up here and go through this chart here. So I have since, let me see if this is still on. Are you still on? You are. So for a while now, I've had my certification through Sandvik, pretty much meaning that I've gone through their test for knowledge and competency for understanding cutting tools and materials, and I've used and applied these skills for many years now. One thing that I want to show you inside of the educational module on the Sandvik CoralMat website is the workpiece materials. This follows this ISO classification according to DIN ISO 513. As well, this here, I'm going to put all these links in the description, but as you can see, P is steel, M is stainless steel, K is cast iron, O is non-ISO, N is non-ferrous, S is superalloy, and H is hard. And if you want a further breakdown as to what these are, you go down here and you read, and you read, and you read, right? It's pretty self-explanatory if you read it all and study. And if you plan on being in the machining field for a long time, make sure that you understand this stuff. You will get the upper hand on the actual machining approaches. I'm going to show a little bit about the Sandvik CoralMat metal cutting knowledge section. So here are all of these things. And there's a lot of do's and don'ts and problem solving approaches inside of here. I would highly recommend that anybody actually take the test, measure their competency, and then study, and then measure, and then study and measure until you get 100%. It's going to help you tremendously. So off of this chart here, we can say that it is good in carbon steel, stainless steel, cast iron, non-ferrous materials, and superalloys. The 2 dots in the blue means it's exceptionally good at machining carbon steels. Now, what if you have an end mill like this that doesn't have a designation on it? Well, that's pretty simple. We just type in the brand name on the packet. We go to the brand's website. We type in this code at the top, 836416, 836416. Enter. There it is. We can click on download speeds and feeds, and we can look at this. So since this end mill actually has technical data for aluminum, coppers, carbon steel, stainless steel, tool steels, titanium, high temp, and hardened or harder steels, we can say that this is a general purpose tool that has actual data for every type of material. The SFM is called out over here. The diameter of the tool is called out right here, the whole way up to 1/2 inch. The depth of cut per the application that you're doing is right here. So this is aluminum alloys. This is castings and wrought. Wrought is like 6061. Castings are like cast aluminum. As you can see, castings 750 surface footage. Wrought 1000 surface footage. Approaches in slotting and roughing and finishing. The chip load for a 1/4 inch tool is right here. That is by cutter diameter. That's inches per tooth. So we have 0.00313 inches per tooth, and then here are the ratios for radial and axial depth of cuts. So now we have determined that this is a general purpose tool. We're actually going to look up this tool in a second. Walter's page is more comprehensive than this one. We have a Gorilla mill. So again, you just go Gorilla mill, weapons of mass production. You type in the actual code, GMA. Now this one's going to be a little difficult because they don't specify the technical data on their website. They have it inside of their catalog. Actually, you can go to calculator. But here is the end mill here, you can either go to catalog and you can find it, or you can go to calculators. We'll go to speeds and feeds, end mill calculator, material, aluminum, method, full slotting, depth, 1 times diameter, tool, and then this is a silverback 3 flute, and it is a 1/2 inch. Now this doesn't take into account your horsepower, so make sure that you understand the horsepower and rigidity of your machine. Here are the speeds and feeds for this tool and this material here, inches per rev, material removal rate, SFM, RPM, all of that stuff. This is going to require a fairly high-end machine to run at those parameters. But yeah, that's how you figure out what this tool is for. You can see here, there's a little brief description. It says aluminum right here, and it says non-ferrous materials. And if you go back to this classification here, N is for non-ferrous materials. Even right here, non-ferrous, aluminum and other non-ferrous materials. So that's the Gorilla Mill. Let me go grab this tool really quick. The last tool we're going to show before we get into the Walter designation is this 3 flute, 2 inch length to cut, 1/2 inch diameter Helical Solutions end mill. Now, most of the experienced people watching, they know it's for aluminum, but I'll show you that it's for aluminum. So we're going to go to Helical. We're just going to type in the brand name in Google. We're going to go to Helical Solutions website, and we're going to type in the code right here, 03495. Okay. Here is the tool, 3 flute square, 2 inches length to cut, 1/2 inch, 4 inches overall length, 3 flutes. Now it's an uncoated end mill. You can buy the coated ones if you'd like. Download speeds and feeds right here. And here are all these speeds and feeds. Now this is only for aluminum. As you can see, there is no technical data for anything other than aluminum. You have wrought, cast, and copper. So I said aluminum, but it's non-ferrous, so wrought, cast, and copper. Different SFMs for different materials. 1/2 inch end mill is going to have these chip loads per the approach here, slot, rough, and finish. If you want a breakdown of the actual technical designations for AP, RDOC, ADOC, LOC, LOC, as you can see here, it says these designations here. So make sure that you read these and understand what they mean down here. So if we're doing a roughing pass with a 1/2 inch end mill, then we go to the roughing traditional with the ADOC is going to be 125 to 200% diameter up to maximum length of cut. So pretty much they're saying that, you might be able to rough with the whole length at 30 to 40% tool diameter, depending upon the rigidity of your machine, your setup, your work holding, your tool holding approach, and everything. So there's that. Now we're going to do the tool that we showed in the beginning here, the Walter prototype with a designation on the packet. So we're going to go to Walter GPS. Walter GPS is the technical data associated with tools. We're going to make sure that it is in Imperial, and we're going to use ISO. Unless you're from across the pond, then you're going to do metric. Search by application. Start. I have acknowledged the terms of service. Tool-related search. You have a couple of things here, application, tool, and online catalog. If you wanted to say that you're machining 1018 steel and you wanted to slot the material, it would give you the best solution for what you're doing if you do this right here. You fill this out. We're going to actually backtrack the tool really quick. So I'm going to click on this, and I'm going to actually type in the order code right here. That was bizarre. We found it, though. So here it is. Here's all the relevant information. Let's go to application. So let's say that we are machining 1018 steel. Let's just type in 1018 here, and then click on this material designation here and select task. And now we're going to say what we're doing. So we're going to do a side mill. We're going to do a side mill. We're going to do 0.25 deep, 0.125 wide, over 6 inches of length. And you can either select dynamic milling, or it's going to do a heavy machining full slot. If you do dynamic milling, you enter the arc angle. If not, you just leave it like this. Operation type. pre-machining, finishing, pre-machining and finishing, workpiece surface condition, pre-machine light and heavy skin. We're going to do light skin. And then system stability. Let's say we have low stability. It's a weak work holding. You're holding it in ER collet. Vertical spindle. If you want to change the machine type, click on this right here. This is assuming that you're using a 268 horsepower with a 500,000 RPM maximum spindle RPM. Good luck with that one. We're going to go down to the weakest machine they have, and we're going to do get results. Has not found a solution. Is it because my stability is too low? There it is. You want to make sure that you have a good work holding stability. It won't recommend speeds and feeds if you have low stability. So there it is. So the inward direction is AE, the downward direction is AP. As you can see, 1/4 inch down, 1/8 inch over. Your SFM is 587, and your FZ is 0.00199. That is feed per tooth. Let me open this up here. There's more information. How much horsepower it's going to consume, how much foot pounds it's going to consume, what your cubic inches a minute removal rate on your block of material is. You can even change cutting parameters. So let's go to here. And as you can see, there's spindle speed, tool life time, estimation, cutting speed, and feed per tooth. This thing does not account for different factors like you're not holding the tool appropriately, you're holding an ER collet, not a hydraulic chuck. You don't have 1,000 PSI of pressure, so it doesn't know these things. You can change a little bit about this right here by going down and turning off coolant types. Now you're running it dry. You don't want that. So let's change cutting data. You can go to this chart right here, and when you increase the tool lifetime, it's going to decrease your operating RPM. Decrease the tool lifetime, it's going to increase your RPM, right? So it's going to give you a rough estimation, but it doesn't know your unique scenario. Is your coolant dirty and populated by a bunch of cobalt and microcarbide? When the coolant blasts on your tool, it's going to be cutting effectively carbide, right? So if your coolant's not clean, there's one. If you're not holding the tool properly, there's two. If your vise is weak and not bolted to the table right, harmonics can occur from that. There's number 3. What is your workpiece? How are you holding it? Is this a light operation? Are you using the correct tool paths? Are you dwelling in corners and heating up your tool? Are you dwelling in corners and hardening your part? Stuff like that. So it doesn't take into account the different programming levels that you might have in your environment or what you might be comfortable with. So just, take that into account. Now, how do you buy tools? Well, how do you find a tool for your specific application on Walter GPS? That's pretty simple. Application related search right here. Let's say we wanted to machine 6061 aluminum. You can use most any end mill for this application, but we're going to choose that. We're going to say that we are not drilling, not turning, we are milling. We're not thread milling or tapping either. We're going to do a pocket. We're going to do a square pocket with a starting hole. Our pocket is going to be 1 inch deep. The width of our pocket is going to be 5 inches. The length of our pocket is 5 inches. And the corner radius in the pocket is 0.35. And the start diameter of the hole in the center of our pocket is 0.950, right? Some weird number. We're going to use dynamic milling, 35%, which means we're chip thinning. And our machine is only a weak little 12 kilowatt, 50 Newton meters of torque machine. Let's say that we wanted to limit our tool to 3/8, so we go 375. Get details. So here's a list of tools it's going to recommend. Let's open up one of them. Let's show detail. Of course, it's going to have you run it at 20,000 RPM. So let's go to change cutting data. Let's do 500 feet per minute, which is going to be 5,000 RPM. My machine likes 7,000 RPM for the maximum relationship between torque output and RPM. So we're going to do 700 feet a minute, which is going to give us the correct thing here. So pretty much it's going to say that it's going to estimate that our tool is going to last 11,000 minutes, which it's going to say our tool is going to last 183 hours of continuous roughing. I can say that's most likely true because I've been using this end mill forever. Yeah, so That's how you find tools that you want to use for different applications, like the 1-inch deep pocket with a 5x5 size and a 350 corner radius. Now, if I copy this, I can actually go to contact and I can go to this link right here. Oh, go to contact and click show more, and we can call this number. Now, when we call this number, they're most likely going to set us up with a representative. Once they set us up with a representative, then you can send them over a request for quotes, unless you have a local supplier near you. So either you can find a representative, or you can go through an online portal or a local supplier. Like DGI Supply, for example, is a place near me that sells tools. If I go to the brands that they sell, these are all the brands that they sell. So if I wanted to buy cutting tools from OSG, I would just go to OSG's website. I would go to milling. I would go to corner radius. If I wanted an end mill with a corner radius on it, I would shop through. I would figure out what diameter I want, what type of material it works the best in. This site runs kind of slow. So as you see from this designation over here, N is for non-ferrous, which is aluminum and other non-ferrous materials. So there's an end mill with N on it. There's an end mill with P, M, K, N, H, and S. So this is general purpose. General purpose is again, non-ferrous again, non-ferrous again. Stainless steel and super alloys. So this is more of a specific application for weird, hard, sticky, heat-generating alloys. So yeah, that's how you would go about this. You would go to OSG because DGI Supply supplies OSG. You would go to contact and you would send them an email, right? So what if you didn't want to go through all that and you were either pressed for time or you didn't want to go through somebody? Just take the code. Most of the time there's two approaches to this. Take the code and paste it into MSC. If nothing comes up, go back to Walter for the list for the tool that you found. And we're going to select the article number, paste it inside of MSC. There it is. It's going to give you the price, 5 business days, add to cart, and then you can go and check out. Now let's go through the general listings on MSC. So if I just type in end mill or tap or drill, let's type in drill really quick. Now we're going to do a screw machine bit, which is a shorter length drill. We can set different parameters. We can do brands, diameters, drill bit wire sizes, drill bit letter sizes, drill bit sizes in millimeters, drill bit sizes in inch, and then different things like a solid carbide drill from Goering. We can actually lock it in there. And then we can change the diameter of our drill. Our decimal inch for our drill is going to be 250 thousandths for a 1/4 inch drill. There we go. And ta-da, we found drills for a 1/4 inch. So you can find different tools on MSC. Let's say that you wanted to figure out what this drill was good for. Copy the manufacturer's number, go to Goering, go to their website, paste their manufacturer's number in there, click on the button, look at what it's good for. So let's go down. Applications, optimal, stainless steel, super alloys. Secondary is hardened steel, but you can run it in ISO P, ISO H, ISO M, ISO K, and ISO S. You don't want to use it in aluminum. Okay, so that's how you backtrack what you found on MSC for the application that it's actually used for. Now let's go through Endmills. So let's say that we wanted to do some, that's high feed, square, back corner, corner radius Endmills. This is where I get most of my Harvey or AccuPro Endmills from. If I'm just looking for a general purpose end mill that can achieve what I'm doing, I go here because AccuPro pops up a lot. Let's say that I wanted a 3/8 end mill with an 1.5 inch length of cut minimum. That's a weird requirement. But you can find it. 1.5 inches. Okay, so we have an AccuPro 3/8 end mill with 1.5 inch length of cut, 5-loop solid carbide, or a ton of other ones, right? It has chip splitters on it, so make sure you take that into account when you buy it. You don't want to purchase an end mill that really can achieve what you want, because maybe this is a roughing end mill. Now let's do tap. Let's say that we want to do an M2 by 0.4 thread. So if I go, spiral point taps are for through holes, and I'm doing a through hole. First, I'm going to do M2 x 0.4, which is a relatively small thread. So I will filter for probably a relatively good brand. A lot of these are 2-week ship times, so I'm going to clear that out and go with Goering. So we have the blue line tap here, and I'm not too sure what they're for off the bat, but Goering has a band designation around their tools, giving you applications at a glance. And I think they might follow ISO P classifications, if I'm not correct. I might be completely wrong on that one. So we have a blue band for this tap. ISO P, secondary, optimal. So it looks like you cannot find this tap on MSC, which is completely fine. Copy this EDP, find the distributor, click on your state, and we have Blackhawk, CT, DGI Supply. Oh, awesome. Does DGI Supply supply it? DGI Supply. Let's go to brands. Goering is not here. Press G. Oh, they just didn't have it up here. Awesome. So go to contact us, company name, message, please quote 1x. Fill this out, send it over. You're going to get an email. They're going to quote it for you. So yeah, everybody, that is the process of how to find tools, purchase them, either through a distributor or through MSC, as well as figuring out what the ISO classification, what the ISO designation on the tools stands for, how to read tools, how to figure out what tools are supposed to be ran at per their codings and their geometries. Until I see you guys again, take care.